Yes. Yeah. Karthik sir. Rajat, I'm audible?
Yes, sir. You are audible.
Yeah, fine. So, see here, there are multiple, various processing steps are there. For there are various processing steps are there to obtain the reflection coefficients. See here, see after this is the reflection coefficients. To the ultimate goal is to get the reflection coefficients from the system data. Those reflection coefficients have the layer impedance and densities about that layers. So any layer, suppose you take a small stone, small rock stone, take it from the road, and how can you say that that stone is the what? How will you define that stone? This is a hard rock stone, or some limestones, or some other any stone. How can you define that stone? Go just come outside of your house and go walk in the some road and take that stone, find any stone and take that stone. How will you define that this is a stone? This is this type of stone. Suppose you can, by seeing itself, you can see that this is water and this is the oil and this is the uh, gold materials. How can you define the gold materials? Using sensors. What kind of sensor they are using? Based on what materials are that is giving that materials, I can, based on that I can see that. So there are some properties of that stone, because that's a impedance layer, density of the stone. Based on the density values, they're defining that stone. This is a hard rock stone. This is a stone which is very slow, loose soil. We can use it for constructing the house. So based on that, they are defined. Each and every material was defined based on the density values, right? So now, so these density values are defined. These reflection coefficients are having about the density values of the layers. From that, we can, from that the layer densities, we can find out whether there is a minerals are there or not, right? So the ultimate goal is we need to obtain the reflection coefficients. After obtaining the reflection coefficient, we need to interpret with the uh, existing data sets, whether derive the density values and interpret with the existing data sets. So our research group is working on seismic data processing and for deconvolution and denoising using AI technique and interpretations using AI techniques. All right. So this is our research group working on this. If anybody wanted to work on this area, please contact us. We can work together. And we are applying. We are the first group applying AI techniques in India level itself. We are the first group applying AI techniques for seismic data processing for oil and mineral applications. And here, and I would like to here, this is a small mathematics models. So after obtaining this, to obtain the RFN, that means OFN is the seismic trace, WF is the seismic wave source, and seismic wavelength, and RFN is called reflection coefficients, and NFN is the noise sequence. So we know that RFN need to be extracted from the OFN, that's called the reflection coefficients. So this is called deconvolution. This is the mathematically which is defined, right? So this is the deconvolution steps which is used for to obtain the RFN from the YFN. See this, I'm finding the YFN, I'm passing this YFN into the FFN filter. I'm going to get this RFN. So what is this FFN? FFN is called inverse filter. So how to define that inverse filter? There are various methods existing. So we are trying to apply AI techniques for inversion techniques, seismic inversions. That means for deconvolutions and to obtain the reflection coefficients. After obtaining the reflection coefficients, again we will interpret with the seismic data sets. So here, and this is one of the method for seismic. This is one of the data sets. This is called geophysical data for oil and mineral applications. And one more thing I would like to say about the ground penetrating radar. What is the meaning of ground penetrating radar? See here, I said about if anybody know about the landmines. What's the meaning of landmines? Means a small dynamite, which is some explosive material which is kept it under the surface, small, suppose 2 feet down or 1 feet down from the surface. If any vehicle moves on that, if it touches that, because of the pressure variations, that explosive material explode, and we are facing a lot of human losses. Recently, also happened in Jargon, I think Jargon or Chhattisgarh. Recently happened a lot of human losses. So that is because of the landmines. So we need to detect those landmines. That is also because why this comes under geophysical data processing means this is landmines also recorded, that means the information, what are the signal processing is happening on the earth surface related to the land. That's why it's called a geophysical processing. So geophysical data processing. So what does the meaning of landmines means? See here, I'm just transmitting, see, from the surface, from the we will fix a small drone on that. So previously they will do detecting the landmines using some humans. A lot of human need to be involved in this. So a lot of failures used to be there. Suppose example, I think a lot of people have went to airport for traveling, right? In the airport there is some checking is there, right? So using some metal detector, there are the police cop or the CRPF, they will detect, they will check your entire body whether there is a metal is there. Nowadays, if you go in Delhi or Chennai airport, they ask you to remove your shoes, and also they will ask you to remove your belts. All right. So they don't want to find any metals in your body. Then only they will allow inside. Right. So next time if you go there and monitor him, how accurately he is detecting that. All right. See here, he will take the metal detector, which is in the 1 feet, and he will find out in the hand, and there is he will press that, and he will monitor the body. Before checking your body, he will check with his belt. He will press it and he will check with the belt. In the belt, there is in his belt, okay, there is a metal in his belt. First, he will press the switch on that metal detector, and he will check with his belt. Then only he will check with your belt. Sorry, check with your body. First, he will check with his belt. If that is detecting properly, then only he will check in your body whether there is a detecting error. Because to cross check and make confirm this is working fine, this metal detector is working fine, because he is doing that for every passengers. So if you're going next time, just monitor how that CRPF cop is scanning your body in the airport. That is means he is using a metal detector to monitor very closely in your body. The closely means, see here, you see the left side, there is an army person who is detecting the landmines. See the distance between the surface and the metal detector. So there's very not even 2-3 centimeters. How it is happening? So the detector sends some signal, right? So in the right side there, you can see that there is one more person who is detecting that. He is sending some signal and he is receiving the signal, right? The same concept, he is sending some signal and he is receiving some signal, and that is based on the reflection coefficients, they are finding that there is a metal or not. All right. So in the bottom there is some pulse, right? That shows that there is a metal is there or not. So based on that, so this involves a lot of human efforts. Also, if there is any failure in the human losses, if there is any failure in the metals, then there will be a huge amount of human losses will be there. In order to avoid those things, we are working on that. We're finding a ground penetrating radar. Radar means we will fix on the drone. Suppose it like this. We will fix on mount sensors which is on the drone. That sensor will send some signals which is penetrate inside the inside the earth layers, inside the earth surface, that will get reflected. Those reflected data need to be processed. That will give whether there is a landmines is there or not. Because how they are processing, suppose keep it there is the drone, we are fixing 2 antennas. One is called a transmitting and one more is called receiving antenna. See, there is called a transmitting and receiving antennas. The transmitting antenna will send some signal and the receiving antenna will receive the signal. The transmitting antenna, which is sending the signal, which is penetrate up to some depth. How much depth it will penetrate inside? 1 centimeter, 100 centimeter, 1 kilometer, 100 meter. How much depth it will penetrate? So transmitting antenna will send the signal. That signal cannot penetrate up to some few centimeters, because Earth is a low pass filters that will not allow to penetrate more than 60 hertz into the Earth. That's why it's the Earth is acting as a low pass filters. That's why the seismic waves is called 20 to 60 hertz. All right. So even if you have a gigahertz, megahertz, what are the frequencies there? You can send, but it will not penetrate. It will be penetrate only the few only low frequencies. That low frequencies will penetrate up to few meter depth. So few centimeter depth. That will the reflectors signals will be reflected. Those reflected waves are absorbed by the receiving antenna. Those receiving antenna as collected by the those informations are recorded and stored. We need to process that stored data to get the whether there is a landmines is there or not, right? So fine here. So we are working on this about the drone, how to process it, and also this is also we need to do some mathematical models on the recorded GPR data that's called ground penetrating radar. So used for detect the landmines. So that the ground penetrating radar outputs are now modeled as mathematics, modeled as convolution models for the reflection coefficients and the seismic on the input wave. So and from noise. So again, we are going to obtain the reflection coefficients. From the reflection coefficients, we are finding whether there's a metal is there or not. Okay. So these are all the 2-3 applications on the geophysical data. So here we are trying to we are the first group. We are working on ground penetrating radar using a drone, and we are trying to apply AI techniques on this. And we are trying to model. We are trying to fix a transmitting antenna and receiving antennas in the drone. Also, we are trying to fix the AI processors, and with that recorded data need to be processed in the using the AI processor, and that will show that whether there is a metal or not, there is a landmines or not. So we are working on this. We are developing some concepts. We have submitted a research proposal to DRDO, and we are working on this recently. And one more thing I like to say. One more thing is see here. There's one more thing called Mars data. Have everybody knows that recently NASA sending a lot of rovers to the Mars, and recently also our Indian ISRO sent one rovers to the Mars to the moon to monitor the minerals is there or not, or oxygen level is there or not. See example. Even I got we are working collaboratively working on a Belgium Royal Society Royal Observatory System on Mars data analysis. What is that means? This is the rover. See in the picture. This is the rover. Rover sends absorbs the layers, minerals information from the Mars surface layers, and that is sending some information to the ground. Now the question is, what kind of minerals are there? How they will find that this mineral is there or not? Exactly. They can find in the some from the surface. They can find whether there is H2O is there or not. They can find there is a oxygen is there or not in the surface, but they can't able to find whether there is a minerals is there or not. Exactly, because to process to find that or to tell that exactly, we need to be there. We need, in the sense, we are the geophysical data person. Need to be there. We are the people working there in those data. We are working hard to find from the Mars data, what are the rovers sent from the Mars. We are working on that to find whether what kind of minerals is there or not. How to say that what kind of minerals are there or not based on the reflection coefficients. What will happen? The rovers, in the rovers, they'll put some 2-3 sensors that will send some signal, and it will reflect that signal. The rovers will send some signals from the rover. It will penetrate into the Mars surface. The surface, it will penetrate up to some few centimeters, and that will get reflected. Those reflected signals will be transmitted to the Earth surface, to the Earth monitoring stations. The monitoring stations data will give to the geophysics people. They will work on the data to find whether there is a minerals is there or not. What kind of minerals based on reflection coefficients only. So we need to. That's what I'm saying. Go to the street today and take a small stone. How can you say this stone is based on what? How can you classify the stones? This stone, this is a hard rock stone, it's a soft rock stone, or loose soil, or hard soil. How can you define it? If they either take it a silver, or take it a gold, or take it any railway wheels, right? So this is one more thing. What is the meaning of this railway materials, right? So there is if you can see one more thing example about this concept is everybody is traveling in the train, right? So in the train there is some lot of wheels are there, right? So what is it? Have you know about the manufacture of the wheels? How accurately should be there that wheels should be there? If there is any small airlock into the manufacturing into the wheels, what will happen? Because of the running, that will be spoiled. That. So how to detect or find that there is an air block is there or not in the wheel? of a train. So that is also signal processing techniques. They are sending some signals, and that will reflect some signals. There is some processing is there. So then they're finding that there is a air block is there in the wheel or not. So these are all some of the applications based on the signal processing and AI techniques for monitoring and processing the geophysical data. So examples is Mars data. So Mars data, that the rovers will send some data. So from the data, we need to process that and finding the, suppose take it, suppose in the earth, we are living in the earth. So in the earth, suppose 200 materials are there. 200 materials are there. Suppose example, all the materials are defined by the with some reflection coefficients and the layer densities. Now, right? Based on some reflection coefficients, all the 200 materials are defined. Suppose in the Mars, there is some new materials there. Suppose in the Mars, there is a new materials there. How can you define that material? Because you will detect the data and you will match the reflection coefficients. I need to match it with the Earth data, which you have we have already defined it. If it is not matching, we will find it something, name it something different new material. But is it a true? Is it a new material will be exist in the universe? So what is that? It's a big question mark, right? So that's what they are doing in the NASA or the Royal Observatories Belgium, and the ISRO IS are also working on this, the moon data. So these are all some few examples about the geophysical processing, geophysical data processing. All right. So and I hope that I explained a few things about giving insights about the geophysical data processing. It's a new topic. I hope it's a new topic for everyone because everybody knows about the various data processing techniques, various data and processing techniques, but it's a geophysical data processing, geophysics, a new topic because very few of them working in this area. And we are applying AI techniques and signal processing techniques to eliminate the noise and to obtain the reflection coefficients. After obtaining the reflection coefficients, we are trying to interpret with the existing data sets to obtain the layer informations. Right. So, and thank you so much for everyone. And hope you people are welcome to our lab if you are interested in anything about the how to process the data, how to interpret the layers, and you people are always welcome to send a mail to us. And we are in XLab, XRMAP, XLab 302. Okay. And thanks so much. If there is any doubts, please, your questions are welcome. And thank you so much.
Thank you, Dr. Karthikeyan. Thank you for your pleasant talk to find out these new research findings. I would like to request the participant. Now this platform is open for you to have a conversations or question answer session. If you have any question, you can directly ask the question. We will give a permission to directly you can discuss with our professor. Or you can, if you have any question, you can write your question on the chat. Another option is that you raise your hand if you want to talk to our professor. You just raise your hand. We will give you the permission to talk to us. Or what you can write to us, mail to us if you have any doubt related to whatever our Karthik sir has discussed about. And as rightly he has pointed out that we already have started our university long back, and we are also coming to the university. Okay, in the meantime, I could able to see some question from Rishi Yadav. I would like to ask Karthik sir to answer. Is there any chance to build another Earth by us?
Yeah, Rishi, it's a nice question. See this, I can build take it about on land surface, take it a small land surface and take it to a small, cut the earth surface from the earth surface, take it suppose 1,000 acres and take it to some different area. So first thing is oxygen and second thing is water. So without these two things, is there any chance to build another Earth by us? So if we can produce artificially about the oxygen, about the water bodies without the any other planet help, we can develop our own. And one more thing is gravity. So this is some person who can work on astrophysics, they can answer it. But I'm a geophysical data processing person, so I may not be the right person to answer this. So you have to address astrophysics people.
I could able to see another question, sir. How could you just repeat how that geophysical data would able to help to find out the minerals which is stored inside the earth?
Okay, fine. See, it's a very nice question. And I wanted to say one thing. Right now we are using petroleum, right? And right now, which are all the countries producing petroleum? Which is supplying petroleum to India? First thing, previously they said is Syria. Because of some problem, we are not going to be able to get it. Right now, Saudi Arabia and Russia and a lot of Gulf countries, they are producing a lot of hydrocarbons, right? They're extracting hydrocarbons from the earth, from the earth, right? So how they are doing that borewell? They're doing successfully borewell, right? So that's what I'm saying. In any particular place, suppose take it in Vijayawada, if I don't know whether there is a earth petroleum is there or not. I cannot do directly borewell for 1,000 meters. Sorry, 1,000 meters or 1 kilometer. I cannot do it because that cost nearly 20 crores. So for that, in order to avoid that, they will send the data processing techniques or signal processing techniques. This is happening everywhere in the world. Example, if you wanted to construct a small, some 25 floor buildings, you need to do this test called MASWR test. That is sending a signal from the earth surface that will penetrate inside, penetrate from the some up to some depth, nearly some 1 to 1.5 kilometer. That will penetrate inside and that will get reflected. Those reflected data have some information about the minerals. So whether they are processing exactly, are you getting the results exactly, or are you? Is it a real time? Is it applicable? Yes, it is applicable. It is a processing. They are getting exactly. They are getting this data. Based on that only, they are doing some borewell and they are getting extracting that oil and mineral from the offshore and onshore also. And one more thing: is there any failure rates? Yes, there is a failure. They are doing. There is a false prediction also is there. They are spending. That's why I'm saying there is a false prediction is there. Still, there is a false predictions. They are losing huge amount of money, but still, I will do some. They are doing their culture is they wanted to do it some 10 borewell. At least one is positive. They will get a huge amount of money. From that, they can compensate because that is different cases. But they are getting 99 failures and 1 success. But that is a failures. The false prediction is there. Still is there. So to avoid that, they are trying to use it AI techniques. It's a new techniques, new data processing techniques. We are trying to predict it. Whether that based on that data processing, based on AI results, can we do a borewell? That is again a questionnaire because we have to spend at least 20 to 25 crores. So if I find a false predictions, then I have to manage with the loss. Then I have to do it one more time. Then I have to do it one more time like that. So there are false predictions. Still, it's a trial and error methodology, but the success rate is huge amount. So yeah, and the money they can compensate if with one success. So they are the people ready to invest on that. For even though they are getting a false, they are ready to face the false losses also. Yes, there is a successfully they are doing that in the Gulf countries about the oil explorations. Yes.
Okay, thank you, sir. I could see one more question. How to get these real-time data so that we can do some work?
Real-time data on seismic data, geophysical data, seismic data, or GPR data, ground penetrating radar data. See, I will tell you with respect to the GPR data. Yes, there are some real data is there. The website there are you can get it from a ONGC also. There are some organizations are there in India. It's ONGC. Do you know about ONGC actually? If you are from Andhra Pradesh, I will tell you what is the meaning of KGP basin. You know KGP basin. They are doing some hydrocarbon explorations. How they are got successfully. KG basin is in the river, right? Reliance is a private industry. He got the approval from 100 years, I think, something like that. So they got approval from the Supreme Court, and they did the borewell, the KG basin, and they are doing explorations. They are doing it. Example, if you are Andhra Pradesh person, then that's example. So if you wanted the real data, there are various agencies are there. ONGC is there, and GAIL is there. So lot of Reliance. So privately means there are a lot of agencies are there. They are doing experiments. They're getting the data, and they are the problem here. Now, what I'm trying to say, what is the difference between if everything is success, then what I am doing? All right, as a researcher, what I am doing means there are some existing softwares. Suppose they take the data and they load the data into some existing software and they'll get some outputs. But the problem here, the existing softwares are old techniques. Suppose still I'm using a denoising for using Fourier transforms. So suppose there are very old techniques, right? So that Fourier transform based on some wavelet transform, suppose some assumptions they will use it. The noise may be a Gaussian distributions. Then the denoising is very easy and they are getting some accurate results. But the noises may be Gaussian distributions, right? I said in the mathematical model, y of n is equal to w of n convolution with r of n plus n of n. The noise, that n of n is noise. So need to eliminate the noise perfectly. So that noise may lead to false predictions. So for the processing of that, we are the researchers working on technique, developing new methods to process the processing the data, simplifying the processing steps, and also getting them more accurately. The existing softwares may not be good techniques to eliminate the noise completely from the data. So we are doing a research how accurately we are modeling the data, and we are trying to remove the noises exactly. So if you wanted to work on the real data cases, yes, there are a lot of agencies are there. You can get it, you can send a mail, and you can approach ONGC. Surely they'll give. If you want, we can work together also.
Okay, thank you, Karthik sir. And there are some few questions. So I am quickly taking up first one. Another question is that the student has written that I have learned Python. How would it be any opportunity for me to work with you?
Yes, you are always welcome to our lab. So we are working in SRM University AP, and which is our lab is XLab. Lab name is XLab, and number is 302. You are always welcome to our lab. You can come and work with us.
And before ending this session, this is the last question. How we can simulate data? Will there be any opportunities to simulate data?
Yeah. There is a simulation data is there. See, you can. That's what I'm saying. So I shown some data sets, right? That is a real data sets, and I'm processing the data sets. So to validate that processing data sets, first of all, we have to simulate the data sets, and we have to update our research group, what we are working on. First, we are simulating the data set, and we are proposing a new method and applying our method on the simulation data sets, and we are getting some results. If we are getting some exact results, then we are applying our method on the real data sets, and we are getting some results, right? So first we are working on simulation data sets. Is it possible to simulate the data sets? And we have the data sets. Okay, that is based on some mathematical equations. We are simulating the data sets.
Okay, thank you, Karthik sir, for your nice explanation about all these answers. I think we have taken up all this question. Thank you very much. Stay tuned with us. We will try to help you as much as possible for us. Okay. And also, obviously, our Karthik sir would be always available in the campus. So please be in touch with us. And we are, based on your feedback, we are going to launch this 5th edition of our workshops very soon. Thank you very much.
Yeah,
thank you very much, ITCAM team, especially our Venugopal sir, for continuously being in touch with us. Thank you very much, Venugopal sir. And thank you very much, Dr. Karthikeyan sir, for your nice talk. Thank you. Thank you all. Thank you all the participants for joining with us. Thank you very much. With all your permission, we are now ending.